Alright, this is problem number 430 out of your textbook. Describes a particle is traveling in a straight line at a constant speed of 25 meters per second. Suddenly, so I'm just going to draw a little sketch here as I go. There's a particle traveling in a straight line with a constant speed of 25 meters per second. Okay. Suddenly a constant force of 15 newtons acts on it, bringing it to a stop in a distance of 62.5 meters. Alright, so it is going to be traveling, it's moving some speed, and it's going to travel for some distance. And then after it travels this distance of 62.5 meters, it comes to a stop. So we're here, this speed at this point, the initial speed is this, and the velocity rather, the final velocity is 0 meters per second, because it says that it brings it to a stop, and there is a constant force, so there is a force acting on it. It doesn't say exactly what direction the force is or anything like that. In fact, that's actually question number 1 for part A, is what is the direction? What is the direction of the force? Well, there's a force acting on this particle, and it tells us that it is a 15 Newton force. We know that the Newton's second law says that the net force acting on a particle is going to be equal to the mass of that particle times its acceleration. And we know that this has some initial velocity to the right, and now it has a final velocity that is 0. And so this that if the velocity is changing here, right? You have the acceleration. We know that there's acceleration when there is a change in movement. So we see this change in velocity over some interval of time from 25 meters per second to 0 meters per second. So that lets us know that there is some acceleration, and this particle has a mass. Therefore, right, there's this associated force. So this acceleration is going to point. So here I just drew the velocity going to the right. You can draw it whichever direction you would like. The acceleration is, so this is a positive value going to the right, so that means it's like a little plus x, positive direction to the right. So when we consider Vf minus Vi, Vf is equal to 0 minus Vi, which is pointing to the right, some positive 25 meters per second over some time interval, which we don't really know. The whole point is that now we're looking at a direction that has a minus value, 0 minus whatever the initial value was. So that lets us know the acceleration is to the left, and therefore, because the force is in the same direction as the acceleration, the direction of the force is also to the left. Well, to the left here because I chose the particle to be moving to the right. So the direction of the force is opposite of the direction of motion, of the initial motion at least. Okay?